Hello children, in this video we are going to discuss 2 or 3 problems related with refraction. So the first question is written here. During refraction of light, which of the following quantities does not change? Velocity, wavelength, frequency. Now let's analyze the statement. Now we know the relationship between velocity, wavelength and frequency. Now the relationship velocity, wavelength and frequency is velocity is equal to frequency times wavelength. Okay. Now if refraction is happening, then we know light is traveling from one medium to another medium. Light is traveling from one medium to another medium. I will draw a diagram here. Suppose this is the interface separating the two media. Let this be the light that is coming. It will be bending, right? So it is traveling from one medium to another medium. Definitely refraction will be happening if the optical densities are different. So we know that if optical densities are different, velocity of light in the first medium won't be same as the velocity of light in the second medium. So if I analyze this equation, if the velocity is changing, then I have to say either my frequency is changing or wavelength is changing, or both frequency and wavelength, the product of wavelength and frequency is changing, right? But in my theoretical class, I have explained that when light travels from one medium to another medium, the frequency remains same. It's a constant, it won't change. When a particular light of particular wavelength travel from one medium to another medium, the frequency remains invariant. So if velocity is changing, then what has to change? Wavelength has to change. So frequency is an invariable quantity. It's a constant, or it does not change. Does not change during refraction. But your velocity and wavelength changes during the refraction phenomena. Hope you understood this concept. Now let's move on to the next question. So in this question it is written that refractive index of water is 4/3. Calculate the speed of light in water. Calculate the speed of light in water. So here they are mentioning only one medium, water. Okay, and refractive index of water is given here as 4/3. I want to calculate the speed of light in water. I can use the concept of absolute refractive index. Only one medium is provided. I can use the concept of absolute refractive index. Okay, absolute refractive index N is equal to velocity of light in vacuum or air divided by velocity of light in water. To represent water, I will write VW. Okay, then what will be VW be equal to? VW will be equal to C divided by N. We know the velocity of light in vacuum, that is 3 into 10 raised to 8 meter per second. The refractive index is given as 4/3. Refractive index is given as 4/3. So if you rearrange this, you will get it as 3 into 10 raised to 8. Then from the denominator, 3 will come to the numerator divided by 4. So velocity of light in water will be equal to 9 into 10 raised to 8 divided by 4. If you solve this, you will get the answer as 2.25 into 10 raised to 8 meter per second. Hope you understood this particular problem. Okay, let's move on to the next problem. This is a little bit kind of complicated kind of question. You have to be very careful. So it's written that orange light of 6600 Armstrong. Okay. Now Armstrong is the SI unit of wavelength. They haven't told that this is wavelength, but here since it is expressed in the unit of Armstrong, it represents the wavelength. So if you have a doubt here, if you want, you can add the term here. Orange light of wavelength. Orange light of wavelength 6000 Armstrong. Armstrong is one of the units that we use to express the wavelength. Okay, wavelength 6600 Armstrong, traveling in air gets refracted in water. If the speed of light in air is 3 into 10 raised to 8 meter per second, the speed of light is 3 into 10 raised to 8 meter per second, and the refractive index of water is 4 by 3. Find the frequency of light, speed of light in water, and wavelength of light in water. So what is to be found out here? You want to find out the frequency of light in water, speed of light in water, then wavelength of light in water is to be identified. These three values you have to find out. It's a very simple problem. Only you have to do is you have to apply the proper concepts here. Okay, now let's write down what all things are given here. Light, wavelength of light in air is given. So I'll write as lambda A, which is equal to 6600 Armstrong unit. And what you have to remember is, if you want to convert this Armstrong unit into meters, wavelength we normally express in meters, you have to multiply it by 10 raised to minus 10. Then you will get the wavelength in meters. Okay, then speed of light in air is given. That is actually a constant. Even if they are not providing it, it's not a big problem for us. Then refractive index of water is given. I will write as NW to represent refractive index of water. Okay, this much quantity is given, and it's said that if you consider this as the interface separating the two media, the light from, suppose this is my air medium and this is my water medium, light is coming from air, falls on the interface separating the two media. If this is the normal, it will bend towards the normal, since water is a denser medium, right? So here two mediums are provided, so it will be having two refractive index, NA and NW. Okay, NA and NW. Now what can I do is, I can use the concept of relative refractive index, that is refractive index of the second medium with respect to first medium is equal to velocity of light in first medium divided by velocity of light in second medium. This is the concept that I am going to apply. Okay, now for that I should know something. What is the refractive index of the first medium? It's not provided, but I know that since air is the first medium, refractive index will be equal to 1. So here my N1 is equal to Na, because first medium is air. My second medium is water, NW. Okay, whose refractive index is given as 4 by 3. So if I want to manipulate this expression, what can I do? What is the N2 value here? 4 by 3 whole divided by, what is the refractive index of air? N1 is air, so that will be equal to 1. That will be equal to, what is the velocity of light in first medium? That is equal to the velocity of light in vacuum divided by the second medium velocity is velocity in water. Okay, so 4 by 3 divided by 1 will automatically be 4 by 3 only. Okay, hope you understood why I have written 1 here, because the refractive index of air or vacuum is always 1. You have to remember that. Okay, so I'll add one more page here. So what happens to my left hand side? It becomes 4 by 3 itself, that is equal to, let me check my previous page, C divided by VW. C value is 3 into 10 raised to 8 divided by velocity of light in water. So if you rearrange this expression, what will I get? I will get it to be VW is equal to, you can take this VW on the left hand side, you can take this 3 and 4 on the right hand side. So this will be equal to 3 into 10 raised to 8. This 3 will go to the numerator and 4 will come to the denominator, into 3 divided by 4. So this will be equal to 9 into 10 raised to 8 divided by 4, which is equal to 2.25 into 10 raised to 8 meter per second. We have several other ways by which I can calculate this value, but this is one equation we have already learned, so I am using this equation. So I got the answer for which sub question? The speed of light in water. So here I am getting the answer for the second sub question, that is speed of light in water. Now first sub question is frequency of light. What will be the frequency of light? What will be the value of frequency of light? What will be the value of frequency of light? I told you that when light travels from one medium to another medium, even if refraction happens, even if bending happens, the frequency will be invariant. So what can I write here? Frequency of light in air will be equal to frequency of light in water. Frequency of light in air will be equal to frequency of light in water, since there is no change in frequency. So if I calculate the frequency of light in air, I can calculate the that will be equal to the frequency of light in water. So let's calculate the frequency of light in air. That is very easy. We know that if initially the light is traveling in air, right? So in air the velocity is equal to c. So c is equal to the velocity of light in air is equal to frequency of light in air times wavelength of light in air. We have studied that v is equal to frequency times wavelength. If the light is traveling in air, then I will write it as c is equal to nu times lambda. I am using the same equation. So what will be my nu frequency in air equal to? This will be equal to c divided by lambda air. Now what is the value of c? 3 into 10 raised to 8 meter per second. What is the wavelength of light given in air? That is already given, 6600 Armstrong units. So you have to convert that into meters. So it will be 10 raised to minus 10 will be coming. Okay. Now if you numerically solve this, you manipulate this expression. If you solve this, you are going to get, I'll add one more step here. 3 into 10 raised to 8 divided by, I can write as 66 into, now here it is 66 into 100, I can write 6600. 100 can be written as 10 raised to 2. So 10 raised to 2 times 10 raised to minus 10 becomes 10 raised to minus 8. Okay, so this becomes 3 into, this 10 raised to minus 8 comes to numerator, so it becomes 10 raised to plus 8. 10 raised to 8 into 10 raised to 8 divided by 66. So 3 into 10 raised to 16 divided by 66. If you solve this, you will get the answer nearly equal to 4.54 into 10 raised to 14. And what is the SI unit of frequency? That is equal to hertz. This unit you might have learned in your 9th standard class. The SI unit of frequency is hertz. So here what I have calculated is the frequency of air. And I know that frequency of air is equal to frequency of light in air is equal to frequency of light in water. So what can I write here? I can write, since frequency of light in air is equal to frequency of light in water, frequency of light in water will be equal to, what is the answer I got here? 4.54 into 10 raised to 14 hertz. Now what is the last thing I have to calculate? I have to calculate the wavelength of light in water. This is very easy. I got the frequency of light, right? I know the velocity of light. Now it is easy for me to calculate the wavelength, because we know that velocity of light in water is equal to frequency of light in water multiplied by wavelength of light in water. Then what will be wavelength of light in water equal to velocity of light in water divided by frequency of light in water. Now what is the velocity of light in water given? We have calculated it in the previous page. Yes, 2.25 into 10 raised to 8. 2.25 into 10 raised to 8 divided by, what is the frequency? 4.54 into 10 raised to 14. So this becomes 2.25 divided by 4.54 into 10 raised to 8. Then 10 raised to 14 comes to the numerator, it becomes 10 raised to minus 14. So this will be equal to 2.25 divided by 4.54 into, now you have two exponents with same base, so the powers has to get added up. So what will I get here? 6, 10 raised to minus 6, 10 raised to minus 6. Okay, now if you solve this, you will get the answer as 4.95 into 10 raised to minus 7 meter. Now 2.25 divided by 4.54 you will get 0.495. So if I rearrange that, I can write it to be 4.95 into 10 raised to minus 7. Actually you are supposed to get it as 0.495 into 10 raised to minus 6 meter. If you rearrange this, you can write it as 4.95 into 10 raised to minus 7 meter. So here I want to once again stress one fact, that when light travels from one medium to another medium, the frequency remains invariant.